Welcome to the Agentic AI series, where we build one agent piece by piece across its whole architecture. In this demo, we cover the run loop, memory and state, and orchestration. This is the big one, because a real agent is more than a single call, it's a process, and that process needs three things. First, the run loop, or runtime, the engine that calls the model, runs its tools, looks at the result, and goes around again until the job is actually done, instead of stopping after one shot. Second, memory and state, the context the agent carries within a run and across runs, so it can build on what it already found instead of starting from zero every time. And third, orchestration, coordinating several specialized agents and steps, one to do the work, one to evaluate it, one to fix it, into a single workflow that drives toward a result. Put those together and you stop having a clever one-liner and start having a system. It loops, it remembers, and it coordinates. This is also why flow is the deepest part of the series. There's simply more machinery here than anywhere else, and it's the part that most looks like production. And that's the real lesson most people miss. An agent isn't one prompt in and one perfect answer out. A single model call is powerful but fallible, so you surround it several specialized agents that write, evaluate, and rewrite the loop, the guardrails and checks, the memory, the tools, and even a human in the loop rating the result so the system keeps learning. It was never really about the code. AI can write that now. It's about understanding the architecture, that a hard problem needs a coordinated system of agents. You don't point one agent at a difficult problem and count on magic. You build a system. Part 3, Memory and State. We've got a workflow that writes, checks, and fixes its own SQL. But so far, it forgets everything the moment it's done. In this part, we give Flow a memory. It evaluates its own outputs, remembers successful SQL patterns, and reuses those lessons in future executions, making it faster and more reliable over time. There are two kinds of memory here. Within a single run, a context object carries every candidate, every score, and the winner from phase to phase. That is short-term memory. Across runs, a Qdrant vector cache remembers past questions and their best SQL. That is long-term memory. The context is what enables agents to work. The cache is why the algorithm gets better the more you use it. Here is the trick: ask the memory before you ask the model. A request comes in. Before doing any work, Flow checks the Qdrant cache for a close match. If it finds a near exact one, similarity above 0.95, it reuses that stored SQL and skips evaluation entirely. If there's no match, it generates and evaluates as usual. And either way, the winner gets saved back to the cache. Old questions are answered instantly. New ones are solved, then remembered. This is the lookup. Find _closest matches takes the new request and does a semantic similarity search. There are two thresholds. Below the minimum, say 0.70, ignore it. Too different to trust. Above the maximum, 0.95, reuse it as is. It is close enough to be the same question. A near-exact hit lets Flow skip the model completely and just hand back what it learned last time.
If you're enjoying this, please like and subscribe so the next video finds you. Now let's keep going.
And this is how it remembers. After a run, if there's a clean winner and no errors, save _data writes that query and its data into the cache, and stores the new ID back on the winner. Notice the guard, only clean winners get saved. We don't want to remember a broken query. That would poison the cache. The system only learns from answers that actually worked. So what's actually in each cache record? The embedding, a vector of the original question, which is how we find close matches. The winning SQL and its score. How long it took to run against the database. And a human rating, 1 to 5 stars, real feedback on whether the answer was any good. Each remembered query is a small, rich record. That rating closes a loop. After an answer comes back, a person rates it, 1 to 5 stars. That rating is stored on the query in the cache. This is the human in the loop. People, not just models, judging quality. And captured feedback like that becomes a learning loop. The system improves from real use. To sum up, check the memory before you ask the model. A near-exact match, reuse instantly and skip the model. A loose match, use it as a hint, but still generate. No match, generate fresh, then remember the winner. Memory, plus the human rating, turns a one-shot answer into a system that learns. In the next part, we step back and look at the whole machine at once.
Thank you for spending time with us. Like and subscribe. Stay sharp, stay Azurite. See you in the next one.